Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and I am proud to be here today with you. I'd like to thank our sponsor, the Precision Metal Forming Association, and the PMA's Educational Foundation for helping to put this show on. We really do appreciate their support. I have the distinct pleasure today of speaking with Colin Hunter, who is the mechanical engineer at Industrial Innovations. We're glad to have him here. Hello, Colin.
Hey, Dean. Thanks for having me.
Thank you, sir. We're glad you could take time out to be here. Our audience really appreciates all of your contributions and time that you're spending away from doing what's making your company money and instead talking about what makes your company money.
It's a good opportunity, and I'm glad to be here.
Great. Now, on the last show, we did have Troy on, and he talked a little bit about his vision for the future. I'd like to hear a little bit of your background and how you came to work at Industrial Innovations.
Yeah, so I am a generation behind Troy. So I graduated college from Grand Valley State, which is in West Michigan, a few years ago in 2014. I've been in industry for longer than that. So like a lot of guys that are in the engineering program at any college, really. I spent some time in a small business to make money while I was in school. Small sheet metal shop, and so I got a lot of foundational knowledge from there. Just being kind of a gopher, doing welding, running some sheet metal machines, and then Grand Valley has their program as soon as you become a junior. So after 2 years of general math, physics, and low-level engineering classes, you're required to, they call it a cooperative education. It's an internship. So starting the summer before your junior year, you intern at a company. And then for the next 2 years or 3 years, however long it takes you to graduate after that, every other semester is either interning or at school. So you're getting real experience, and hopefully the company that you're with is giving you very good experience. And I benefited greatly from my co-op in doing real industry work while you're in college. So you're not graduating and then exposed to the actual industry. And this is a really good thing because it's good for Grand Valley because they can hammer a lot of academic things, but you can also learn industry things at this time.
Right.
Because I believe there's a lot of academics, I'm sure we'll hit some of this, but academics has kind of a sour taste for some people because it doesn't adequately prepare you. But there is a lot of learning how to do things, how to learn things, how to manage your time, how to be organized that you do through the academic environment. But most of the things that I do from a job standpoint, I learned through the co-op with the first company I worked for, JR Automation in Holland. I was very green when I started co-oping there, but by the time I graduated, I was able to hit the ground running and contribute to the company as a full-time mechanical engineer, and we'll be working on projects with people from the get-go.
Mm-hmm.
So after I graduated, I was with JR for a number of years as a mechanical engineer, a machine designer. We designed and built custom automated assembly equipment for a bunch of different industries, for automotive, for consumer goods, electronics, textiles. So I got to see a whole lot of different industries, work with a lot of different kinds of engineers, I stepped away from that industry for a little bit last year and worked in the transportation seating. So I worked for a company that supplies bus seating for about a year, and then realized that wasn't for me, and that I needed to be back in the equipment business. And so now I'm here with Troy and everybody else here at Industrial Innovations.
Great. I think that you're close enough to the educational system now. Would you say that the schools now are focused more on the mechatronics programs? Because I see that as being one of the areas that a lot of schools are shifting towards.
Are you just clarify that a little bit? Are we talking? We going to talk college there, or high school, or both?
In college, basically,
Okay.
A lot of the schools have, rather than focusing on the disciplines of electrical or mechanical, they've kind of looked at a hybrid of, instead of calling it mechanic or manufacturing engineering, they have these mechatronics programs.
Yeah, so that's a good one. Grand Valley in particular has they still pump out a ton of electrical engineers. They obviously pump out a lot of mechanical engineers because as a high school kid, you don't really know what's out there, and so okay, I'm just going to do mechanical engineering because it's really broad. There's some kids who have a really great idea of what they want to do. Maybe they were exposed to something because of family or because of high school experience or something, so they've got a better idea. I was more in my dad was an engineer, he was a mechanical engineer, and that's what I knew, and figured that I would take the broad route. But they have Grand Valley has a program called Product Design and Manufacturing, which is a little bit misleading because it does actually hammer the mechatronics and the intersection between mechanical systems and how you control them.
Gotcha.
So they actually, that program itself does a really good job preparing controls engineers, because it does a lot of, like, you learn manufacturing processes, you learn some machine design and some physics, but the electives for that route are much more modern, I would say. And the projects that they do, Grand Valley, you do a lot of projects. Like, you get your own normal homework, your book work, but you are going to design and build a lot of things as a team. And the product development and manufacturing major there, and I'm sure most schools that have a good developed program probably have something parallel. It might be called something different, but those projects were all the intersection between taking a mechanical system and making it do something.
Right. Now, if you were to look, kind of one of our focuses here on the show is looking at the destiny of manufacturing, so taking a 5-year perspective, where do you see manufacturing going in 5 years, and how will things like our education for those students change, and how can we better shift to meet the demands of manufacturing?
So on the previous podcast that you did with Troy and my boss, you guys talk about robots a lot, and that's one of the heavy hitters. He mentioned he got to see robots coming up through the industry, and before people didn't know how to implement them or what to do with them. And that was within the industry. And now we see general public, people who don't work in manufacturing, hear the robot buzzword. And so everybody kind of knows that they exist. Not a lot of people, if you're outside the industry, know what they do, how to implement them. And even within the industry, there's a lot of old companies that have manufacturing systems that they're trying to implement robotics and not knowing how. So a big part of it is, first of all, understanding what a robot is. Basically, a robot can really be anything that moves autonomously via programming of some sort in 3 or more directions. So I've had equipment suppliers just call some 3-axis servo-driven machine a robot, and that's true. In the classic 6-axis robot arm sense, collaborative robots are big, and I think that's not big, they're coming up. And that's a very good example of what do you do with it, because it's expensive to implement still. But finding out how to make robots and humans work is going to be a big thing over the next 5 years. And I think I've got a few examples for that. There was a project I had the privilege of working on with my former employer, who was an electronics supplier, and they were assembling electronic circuit boards, and there's a lot of little tiny parts, and they have to be assembled with high precision. And we had a job with them that we were in their plant talking to their engineers about and working on development for. But we were also kind of doing a sales call and seeing what else we could do with that platform, because this was a specific part of a much larger assembly process. And one thing that we found there was that process it benefited greatly from manual assembly, because the pieces were so small and so particular that as the industry stands now, it was hard to make robots work in the context to put these pieces together, because so much of it was, okay, I'm going to take this little piece, apply pressure with my fingers here, and when I feel it click into place, then I'm going to slide it over this way. And you can't, at this point, it's hard to know how to quantify that and how to make a robot do it. Like you'd be surprised at the things that I can design. Like I can make a robot gripper that can grab anything or put anything into anything, but the forces or the pressures that are involved are some of the things that we really need to get better at. So how do you make a robot feel and report back and interpret that information to feed back to the robot itself that it can do these weird things? And so making robots and humans work together side by side, actually applying this collaborative robot technology is one thing. Another thing that you're seeing in the schools is 3D printing, not even just in schools, but in industry. That's kind of the thing that popped up when I was in school. Grand Valley had a few 3D printers, and there were some people that were allowed access to them. It was not the level that it is now, where anybody can go buy one for their home if they want to and learn how to program it. So I think, in addition to robots, 3D printing is something to watch and figure out how to implement. And it's kind of buzzwordy. And if you go on blogs or podcasts, people talk about how it's gonna take over. And I've been very skeptical about it, because I mean, the stuff that comes out of a 3D printer is not rated for consumer use in general. Like you can't 3D print steel yet. So a lot of the stuff that we interact with, it's not applicable yet. I will say that just in the past few months, Nike, the shoe company, has debuted a running shoe where the upper is 3D printed, but that's currently only available to their top level marathon athletes. And so it's kind of coming to the forefront. And I might have to stop being so skeptical of it, but it's slow. And so I think that might be one of the things that we see in the next 5 years as well.
Yeah. I think you bring up a few good points there on that, on where 3D printing will be and the volume that can really handle. I think that to make it where it's high volume, that's going to take a lot of work, or you just have to have a lot of machines, in order to accomplish that.
Right, and I think that the key is, as with robots and as with any new technology, the key is going to be what's the smart way to implement it. Because as with the project that I talked about a few minutes ago, there's no point in putting a robot on something if it doesn't benefit you. That's one of the things that I learned fairly quickly, is that you need to make, if we're designing equipment, we need to make what we're designing work for the customer. There's no point in making something really complicated, even if it's fun to draw up on the computer, or if it's a more interesting machine. If I can do something with 2 axes of motion, then a robot becomes unnecessary, because you want something that's going to work for the customer.
Mm-hmm. Yeah, I think that we don't have to try and find an application. It's almost like sometimes we do search for an application to fit a technology, as opposed to the technology driving that equipment.
Right.
If you were to take a look at kind of the 5-year picture of technology, where do you see some of the areas where we have to continue to develop on the workforce side and education?
Yeah, I think this is my answer might be a little unexpected. So robotics are the popular and attractive thing, right? So first robotics is a thing in high schools. And one of my younger brothers is actually, there's even lower levels of first robotics. My little brother is involved in one called Lego League, where they just do these problems similar to what first robotics kids do, but on a smaller scale. And so people know about robotics and that, hey, these are real careers that you can pursue. And so getting into it is, on the forefront as young as possible, is good. But ultimately, businesses need to be able to support themselves and support growth. So one thing that I think people need education on as soon as possible is following processes, and also the business environment. So things like ERP and PDM, where there are so many different departments of a business that have to interact with each other. And we're not in an age anymore where I can just write notes out or download a Word file and fill it out by hand and hand it over to this person over here. I have my deliverables as a mechanical engineer are drawings and BOMs. And there are people downstream of me who need to be able to access these things. And so there's a lot of companies out there who probably have home-brewed, half-baked ERP systems, so enterprise resource planning, which I've been in this situation where it doesn't work like you need it to, and so people have to do more work just to get prints to a sheet metal supplier, for example.
Right.
And so when we talk about Internet of Things, everything is connected to it. Everything is connected to everything else. I think people learning about the systems that a business runs on and how business processes work sooner than later is better, so that we can better develop streamlined systems so that the mechanical engineers, the electrical engineers can supply people with their deliverables, or so that salespeople can get me the information I need easier, because we want to reduce waste and reduce non-value added work. So we want to reduce stuff like paper pushing, and I spend 3 hours a day just trying to get files to different people. That's something I didn't know existed until I got into industry.
Right.
And I think that's probably true for a lot of people.
Yes. Yeah, there's... Now, do you think that you'd mentioned robotics, about the robot competitions? Do you think that things like the Lego League and First Robotics and Vex Robotics, that these are getting kids back interested in STEM and into manufacturing possibilities?
I think they are. It's kind of complicated, because there's a lot of those kids that get interested in those programs probably would have been anyway. I think that the hardest thing that you're fighting there is quite simply high school kids' stigmas, where the nerds are the ones that do that stuff. When I certainly wasn't. I played football. I was more interested in sports than interested in math and physics. So I didn't have any interest in those things until my parents kind of cultivated in me the idea that I'd be good at it, and kind of softly guided me toward that college program. And so, or maybe my boss, Troy, he talked about how he was involved in shop classes and stuff. And I don't know if this stigma was there when he was that age, but now, if you hear people talk about those things, it's the burnout that are involved in shop classes, because you're not smart enough to go to AP Government or AP Calculus. And I think that's really unfortunate that we have to fight that battle, because kids that age don't know how rewarding and fulfilling careers in those industries are. Like I certainly didn't know that electricians were employed by machine builders to wire up these giant assembly cells, and made a lot of good money doing it. I thought electricians just went and pulled wires in houses, but no, these guys are putting together these really complicated, intricate control panels. Same for plumbers. Plumbers aren't just working on kitchen sinks; they're putting together pneumatic and hydraulic systems for very complicated machines. And so yeah, I think that to get back to your question, First Robotics, I think, does a good job of getting kids a head start on, okay, this is how to design a mechanical system. This is how to interpret specifications and what we need this machine to do. I think that the next step is, okay, how do you attract more than just the nerds to those opportunities?
Yeah, I think that is a challenge that we have, and probably over the next 5 years, we're going to see exactly, whether what we're doing today is having an impact, or if we need to change directions in order to get more people interested. It's something that is a challenge to get people interested, getting people. I think that's an early step. Is how do you get an interest there?
Yeah, it's unfortunate. It's really unfortunate that we have to fight these dumb little battles like stigma between, oh, you like physics and you like robots. Well, I'd rather go play basketball. Well, you can do both. You
Right.
can be interested in both. And I think that the tide might be turning. But that's definitely, I think, a battle we have to fight. It's unfortunate.
Yep. Well, Colin, thank you so much today for being with us on our show here at the Destiny of Manufacturing. We'd like to thank our host, or our sponsor, the Precision Metal Forming Association and the PMA's Educational Foundation for sponsoring our show. And again, Colin Hunter's been here from Industrial Innovations, and we really appreciate you taking the time, sir. And you have a great day.
Thank you. You too.